There's nothing crazy to it. It's basically the same stuff that we've been working on. There's no reason for us to change it through. The idea is that you have to be able to draw a diagram, label something, and fill in the blanks. You know how the algebra works. That's pretty straightforward. That hasn't changed up at all. No, thank you. So let's just kind of briefly go through a few things, just to remind ourselves. Now, when we first started chapter 1, we talked about how things were labeled. For example, if I wanted to label a line has how many points? Maybe 2 points. And what's the other way you can label the line?
A, B.
With line A, B, the double arrows. What's another way you can write a line? I can do BA. What's another way you can write a line? No. What was the other way? What's that? No. You only need 2 points for a line, guys.
Segment?
No. What's another way you can write a line? That's the other way for this one, yes, but what's the other way?
OBA?
What is it?
Does it have like a bisector?
No. What's the other way to draw a line, guys? Or write a line?
Right.
What's that? No.
Right. Reciprocal? Angle. Right.
Within the BA.
Vertical?
Let
Right.
us keep guessing.
Guys.
No, let us keep
Guys. This is not crazy here, okay?
It is.
I'm asking, what's another way to write and label a line? Yes, this is line AB, or this could be line BA. You've all said that. I have not said anything about angles. I haven't said anything about bisectors or things of that nature. I'm just asking what's another way you can label a line. The answer is a lowercase cursive letter. That's what I'm talking about. Wow. So we all forgot that
It
apparently.
only has a lot of
Yeah,
ones.
because we never really.
Yes, we have.
What was
Go
the
back.
other way you
Once.
said?
Bless you.
Once.
What was the other way you said?
For 5 minutes.
We also talked about when you write lines, when you write segments, how many points do you need to write out? Two. You only need 2. There are 2 things that we've talked about in class that need 3 letters. What's one of them?
Opposite.
Angles need 3 letters. Let's break this out. What else needs 3 letters?
A plane.
Bisector.
A plane.
A plane. Very good. A plane. What makes a plane? What makes a plane? You're right, it's flat sheet, you're right. But how do you denote that you have a plane? Yes, sir?
Because you have flat surface and same coordinates.
Yes. You need 3 non-collinear points. For example, remember we drew it out a lot of times, it looked like a parallelogram? ABC. Oh, that's right. I always forget that. There's 2 L's in collinear. Doesn't seem like there should be, but there is. It's like a llama. There's 2 L's in llama. Why?
Why not?
So, in this case here, we would call it plane ABC. You don't have to, there's no like angle, or it would be like segments, or there's no bar or anything put over the top of it. It's just plain ABC, or BCA, or CAB, any one of those. Now, what's the other way that you can write a plane? Bless you. That was the line with lowercase cursive. A plane is uppercase cursive. For example, plane R. So another one you can write instead of lowercase, or excuse me, 3 capital letters, you can also use a capital cursive letter as well.
How do you know that R isn't a point on that plane? Is it cursive?
There's no dot next to it. Perfect. No dot next to it. It's an easy way to remember. Okay. Now, put away your phone. Seriously, if I tell you again, it's going to go sit on my desk to the end of the period. Put it in your pocket. Unplug it from your Chromebook. Just put it in your pocket.
Your roots is don't break.
Okay. All right.
You just say that.
So remember, when you're reading these things through, that's the kind of stuff that you're looking to do. What is the important part with angles with their 3 letters? What's the really important letter in an angle? The vertex, which is always the what? Good. So if it's angle X, Y, Z,
It's Y.
Y would be the vertex. Good. All right, good. So we have planes, angles, lines. We know segments. Segments is when we started doing a lot of the math then. As you get into segments, it was a portion of a line that's measurable. Obviously, lines are infinite, that's why we don't measure them. But with a segment, we could actually just measure, which means you can do segment addition. Which, remember, segment addition was really simple. If I just put a point in here, we'll call it B. If this is 6 and this is 8, what's the whole thing?
14.
14, exactly. But then we also were able to start doing things like this. Where it says points A, B, and C are collinear. What does AB equal? What does BC equal? Oops. And then obviously what does AC equal? Now, when you have something like that, when you have points A, B, and C are collinear, and I think the instruction said that B was between A and C. Obviously, you can probably figure that out when you're looking at the lettering. See how it goes A, B, AC, and then BC? That means if you draw that, B is in the that doesn't have to be in the middle, but it's in between. So we had problems like this, where you guys had to do what? Math, right. But you had to draw a diagram. You draw a diagram, and you label it. AB was 8, AC is the x plus 18, and BC was 2x plus 18.
Oh, let's do.
It don't look right, so.
No, that's,
That doesn't look right.
yeah, that, of course I picked one quick example that has the wrong value. It doesn't work like that. Oh yeah, look at that. That's just not going to work, is it? Let's try a different one. Why would they give me one like that? Makes no sense.
No, it actually will work, we just get a negative value for x.
Oh, that's true.
But then we plug it in and it works.
Okay. And that's right, because remember, we could have negative values for x's, but we just substitute
Yeah.
through. Okay.
Yeah.
Of course, I would check these things. I didn't check it before I put it out.
All good.
I know, I just pressed the button and it made parts for us to look at. Right. So, write the algebra. 2 smaller chunks equal to larger. So we write it out.
Oh, we got it.
2x plus,
I thought it
Okay.
equals
combine like terms.
Combine your like terms. Okay.
18 plus 8 is.
We have 2x plus 26.
26.
Alright, 2x minus 26 on each side.
Okay, so bring the x over. So x is going to equal negative 8. Yes, ma'am.
Yeah.
Oh. Is that 18?
Oh, this was an 8. So I was doing AB plus the BC. Oh, was the plus there? I
Mr.
got you.
Murphy. Oh, I was going to say up in the
The what?
up on the
Oh. So you get your negative value for x. But when you substitute in, what do you get for your values? it works, okay? And that happens. You can have a negative value x, but you substitute in, you won't have negative value of segments. So if you substitute the whole thing, we get 10. And then what's this chunk here then? 2. Very good. All right. Segment addition. Segment addition was not overly complicated. It was just a matter of putting two things together to make it work. Now, what would a segment bisector do? What would you do with the segment bisector? They're equal. So if you have a bisector, I think that was this section. A segment bisector or a midpoint.
Hey, Mr. Murphy,
Yes, sir.
when you get a chance, can you go back to the problem?
Yeah. In this case here, we have a midpoint. We have it's been bisected. Remember, a midpoint is a segment bisector. It's just, they just call it a midpoint. Yes, sir.
Don't you just like, put an equal sign when you solve it?
Pretty much. When you see those tick marks, when you know that you have a bisector or a midpoint, you set them equal to each other. Okay. So when we write that out, excuse me, we have the 4x minus 12 is negative 2x plus 21.
Add 12.
Well, pick on the little guy first.
Plus 2x on each side.
I'm going to add the 2x to both sides, and then at the same time I will do the 12 as well.
Plus 12 on each side. So 6x equals
3.
And then divided by 6 on each side.
Divided by 6, excuse me.
Then x should equal to,
It should equal 33 over 6, sir.
And divide both by, you get 11 over 2, 5.5.
then
Okay.
we plug 5.5 into the x.
Correct.
So 4 times 5.5 is
Well,
some
very
number.
easy to look at here. If you double 5.5, what do you get?
22.
Try again.
No.
11. Now, if I'm trying to find MR. If I
Yeah.
double 5.5, I get negative 11 because it's a negative 2.
Yeah.
What's negative 11 and 21?
Negative 11 and 21 is,
What's 10? Which, now if you just plug it on the other side.
If you go to the other side, you do the same thing.
They'll
If you
get-
double 11, or if you double 5.5, you got 11. You double it again, you get 22 because that's 4. When you double something twice, it's times 4. Subtract that, and you still get 10. Good thing to do is always double check your work, make sure you're getting them through. Okay? It's not overly crazy to work with. Hopefully you do rather well. Now, also when we dealt with segments, after we did midpoints and we did bisectors and things like that, we also did distance.
distance.
We did distance,
My bad. All right. I'm sorry. I'm ruining it.
we found the actual midpoint, and then we found the missing endpoint. We did all 3 of these things with ordered pairs. And you did that on your quiz too. Some of you guys did really well on that, some of you guys kind of forgot how to read. So, distance. There's a couple of ways of worrying about distance. You can actually use the long form of the distance formula itself, where the distance is square root, change in x, quantity squared, plus change in y, quantity squared. But we also did it a lot of times in terms of counting, because we just logically walked through it, and it was a little bit easier, a little bit less cumbersome, if you will, as we put out those points. So let's look at an example. Let's say we have negative 4 and 3, and let's see, 2 and 11.
Okay.
Okay? And we'll go both ways with it. We'll walk ourselves through it the long way, and we'll also do it the logic way. So if I'm looking at the long form, I'm going to use the formula, which means I would fill in the blanks.
It's 6 and 8.
6 and 8.
2 minus the negative 4. 11 minus 3. So you have your 2 minus the negative 4, which you guys have said is 6. You 6 squared, you get 36, very good.
36, 64.
And then 8 squared is 64.
100. Yeah.
And what's the square root of 100?
10.
10, very good. So our distance here is 10. That's using the formula. Nothing wrong with going straight through the formula. Now, as you sat there and listened what we were doing, we were actually saying all of the stuff anyway. How far apart is negative 4 and 2? They're 6 apart. I square it. So we knew that right off the bat, from here to here is 6. I square it. I add to it. How far apart is 3 and 11? 8. I add them together. And I just take the square root of it. I'm doing the same thing, but without writing it out long form. Okay? It just seems, a lot of times, it's just less cumbersome. It's a little bit easier to think yourself through it a little
A
bit.
little less complicated.
Yeah, try to at least. Now, what do you do with midpoint? What's that?
Okay, we figure out the distance, then don't we divide it by 2?
Yes. That's all it is. You find out, you're taking your x values, add them together, and cut it in half. Yes, ma'am?
How is 10 the same as 6?
It's 6 squared plus 8 squared. And then 36 and 64 is 100. You take the square root of 100, and that's it. That's where it comes from.
Just add 6 and
So your answer could be 10 apart 6 and
No. What happens here, I didn't finish this out. When I finish this, I get the square root of 100, which equals 10. So that's how far apart those are.
Okay.
Okay, I just stopped because I just did it. That's all. I should have walked through the rest of it. So when you do midpoint though, if we use the same ordered pairs, I would take negative 4 plus 2, cut it in half. 3 plus 11, and cut it in half. What's negative 4 and 2?
Negative 4 and 2 is
Try again. Negative 4
6.
plus 2.
negative 2.
Is negative 2.
Negative 2, good. What's half of negative 2?
Negative 1.
Negative 1. So the midpoint for this case would be at negative 1, comma. What's 3 plus 11?
3 plus 11 is 14.
14. That's half of 14.
7.
That's how you find midpoints. Okay. That's how that works. Add them together, cut it in half. Make sure if you're using your calculator with that to use your fraction bar. Because if you accidentally type in negative 4 plus 2 divided by 2, you're going to get negative 3, and you're going to be wrong. Okay. Now, what if this was a missing endpoint problem? If we had one endpoint A was at negative 4 and 3, the midpoint was at, what was it, 3 and 11? No, 2 and 11. It was 2 and 11. And we needed to figure out where B was. What did you do?
Oh,
No, I yeah.
Okay.
Yeah, I got it.
Mr. Murphy.
Yes, sir.
Don't we add negative 4 and 2?
This is the case here. Yes, sir.
Okay, so what you do is, since the midpoint is 6, you add another 6.
Yes. And that's where I was getting. When you're trying to find that leftover point, that missing endpoint, you just remember you're either going up or down the ladder. We know that right now this 2 value,
We're going up.
we're going up. How many? From here.
6.
What's 6 more than 2?
8.
There you go.
8, and then you'll add 8 to 11, and then that'll give you 19.
That's it.
My birthday number.
So when you walk through those things, you have to remember to read it. Are you looking for distance? Are you looking for midpoint? Are you just looking for missing endpoint? All right. It's reading. And then after that, all the endpoint stuff and the midpoint stuff, then we switched to angles. And we had acute angles.
It's 90 degrees.
We had obtuse angles. We had right angles. We had straight angles. We had vertical angles.
180.
We have horizontal angle.
No, we don't. We had linear pair.
Then we have a collinear pair.
Yeah.
Sorry.
Complementary. Supplementary.
That's
What's
a lot of angles to remember.
Linear, we have linear pair, adjacent, thank you, adjacent angles. I want to show you guys, we're going to do a picture of all these.
Each other. Wait, so they're
So let's go
basically-
through and draw ideas of what they are. Sir,
Can I go up?
well, I want to go with everybody through it because we don't have that much time.
Acute is less than 90.
Acute, acute angles, remember, acute angles are less than 90 degrees. Give me a number that's less than 90. 47, there you go, 89.
0.00.
There you go, there's an acute angle. That's less than 90. Okay. Obtuse angles, larger than 90. That's a straight angle. There you go. RT, right angle. A right angle. Right angles measure how much?
90 degrees, sir.
Gotta put a little box in the corner then.
And then straight is just straight line.
A straight angle is made up by,
Of a line.
how about this? What if I called it opposite rays?
180.
180.
Don't, it's 180 degrees. A straight angle measures 180 degrees. It's made up of two opposite rays.
Yeah.
Opposite rays create straight angles. Okay? Vertical angles.
It's going up and down.
Vertical angles are the ones where you had two lines that intersected.
Yeah.
What?
When you had two
Yeah.
lines that intersect,
Oh,
the angles that are opposite one another are congruent. Okay? The ones opposite one another are congruent. Linear pair. What is a linear pair?
Oh, goodness gracious.
Good. Linear pair are adjacent angles that create a line. So basically, all you have to do is that.
Oh.
And that's a linear pair. A linear pair is two adjacent angles that form a line. Adjacent angles are angles that are that share a common vertex, but and a side. That's a very easy definition for them. Complementary angles are what?
Are
90. Less than 90.
Two angles that add up to equal 90. So if I say angle 1 and angle 2, hey, look at that, they form a 90-degree angle. They could be 45 to 45. Do these appear as though they are the same angle?
No.
Nope, not necessarily.
70
supplementary
and 20.
is- She's on fire. I'm not.
So angles 3 and 4, these guys create a line. They're supplementary. Now,
You got me.
when I go through, do complementary and supplementary angles have to be adjacent?
no.
No. Nope. Now, the last one there was the adjacent part. I should put that one first, 'cause it's a little bit more important. When you have an adjacent angles, they are angles that are next to each other that share a vertex. And it's a very simple thing to draw. Those two angles are adjacent to one another. Yep. They share the common vertex and no interior points that intersect. Very, very straightforward. Other than that, if you start thinking about the other bits and pieces with this, as far as the algebra stuff, is the angles, because you can have angle bisectors, angle addition, which is the exact same thing as second addition.
Wait, what's an angle addition?
Two smaller angles add together to make a larger. Angle addition.
ADD?
Same basic idea here. This is an angle addition style problem. We're going to find the measure of angle BCD if the whole thing is 12x minus 5. Sorry, that line came through. And then this little part, the YCD, is 30. And BCY is 8x plus 9. So again, two smaller angles add up to equal the larger. So if I write it out algebraically, like we have before,
30. 8x plus 9.
And notice how the algebra becomes exactly the same as seconds.
Combine like terms.
Okay?
So we have 8x minus plus 39
Okay.
equals
Let everybody get caught up here, okay? I appreciate it though. You have the 8x, 39, 12x minus 5. Let everybody get caught up, please. Thank you. Variables on both sides of the equation. Remember, you always want to pick on the little guy.
yes.
Subtract the 8, add 5 at the same time. So we have 44.
Divided by 4 inside x equals 2.
And then lastly, to ask you to solve for the angle BCD. You can substitute back in. Remember, and that's the thing here. When you're working with the algebra, the geometry, you're using the definitions off of it to set up the problem. So you just go back and substitute in 11 times 12, and I believe that's 132. And subtract 5, and I think we get 127. All right? That's English. Something. It's definitely something.
Is there an angle subtraction?
No, we don't worry about that because you don't worry so much about angle subtraction, but isn't it the same as adding a negative number? Yeah, that's it.
Is there such thing as angle multiplication?
No.
That would be.
Take a second and solve this one out then, please.
Try it. Maybe 141x.
Got it.
Good for you.
Please don't say that.
So again, two smaller chunks added to equal the larger should not be horribly bad. Move stuff around here. I believe we get 2x plus 170, I believe.
Yeah, that's not bad.
So you have so you get -1. Is that okay?
Yeah, 1.
But then what do you do?
Infinite plug
Yeah, you substitute back in.
184x.
So if they're asking to figure out WBA, well, what's 141 minus 1?
140.
And then the other one would be 28. Hey, look at that. Put them together, you get 168. Go figure. It should, because that's what it says. Oh, I forgot. There was one other angle thing that we didn't talk about. Congruent angles. How do you draw congruent angles?
Oh,
Isn't it angle
same
that is
angle.
congruent to
How do you
one
show that
another?
they're? How do you show that they're
two
equal?
angles that are the same. You put the
One
tack
big
mark,
angle
the tick
and
mark,
another one.
Tick mark. There we go.
tick tack mark. There you go.
Can't they use this as an example of vertical angles are congruent because you have those little tick marks?
No.
That was one other one on there I wanted to remind ourselves of. So what I usually do for the days before tests and stuff like that, I always try to assign you guys some review problems because I want you guys to
We have a test tomorrow.
go through and do well on it. So let's see.
We have a
What
test
is
tomorrow.
short?
Yes.
Alright.
if I look over to page 60,
No.
yeah, in the book. I go to page 60, and I think we can go 1 through 31, yeah. So, the chapter review that I want you guys to do
Page 60. Yeah.
let's do numbers. Yeah, we'll do numbers 1 through 31. Oh, I'm sorry. I thought I wrote that on. I said it out loud. It's on page 60. And I want you guys, there are examples of everything that we're going to do tomorrow. All right, we've got pictures from the planes. We have segments for segment addition. We have endpoints, missing endpoints. We have midpoints, angle addition, complementary, supplementary angles. It's a mixture of everything, guys. There's no craziness there. I would spend my 25 minutes or so doing those. It's a little bit more than I normally assign, as you guys know, but
What's the date?
putting it for a test is just going to help you do better on it. All right? Seriously, it will. Walk through those, and then we'll test it tomorrow. We'll start logic then on Wednesday. That's the plan. It's something. Logic is definitely something. Excuse me.
Did you write this assignment down?